All right, so let's take a look at this fantastic game that we have pre-built for us. Now, I will say, I did put all of this code in Canvas. It's there right now, but I did not put the sprites. So what you're going to need to do before the code will run is you're going to need to find some sprites. You'll need to find a jet and an enemy or a missile. And you can literally just hit Google Images up for that. You can download there. If you just do like tiny jet sprite, you'll see a 1,000 different options. Okay, so you can use that, and then you're going to modify this for the jet and this for the missile, so that they match up with your file names and locations. Okay, so you can do that, and then it should run. You may also need to make sure that Pygame is installed by looking here at the installation. In PyCharm, it's going to be the package installer. If you're using vanilla Python outside of this class or whatever, you're going to want to make sure that Pygame is installed. Otherwise, this won't run. All right, so let's hop into the code and take a quick walkthrough so I can kind of explain the parts. It does have quite a few comments in here, but they'll make more sense once we walk through it. Okay, so first thing we got to do is import things. We're going to import the entire Pygame module. We're also going to import random. We use random throughout the game to help us make the game more interesting. We don't want missiles that all fly the same speed, start at the same place, and do the same thing. We want to put some randomness in it. It makes the game more interesting. So there are lots and lots of games that use random. I would say probably more games use some kind of a random element than don't. Even games that have AI or things like that built in still use random, because the randomness is what makes the game replayable. If it's exact same game, exact same moves, exact same enemies every single time, it gets boring. So random is good. We're also importing pygame.locals. Well, from pygame.locals, we're importing these specific constants. Remember, a constant is a variable that is in all caps, doesn't change, and represents something. When we are importing these values in these, in this case, an algorithm choice, we're doing that because those represent something that's way more complicated. This is one of those things where it makes it easier for us. RLEXcel is a graphics acceleration that helps us when we're rendering sprites to the screen. Keyboard up, down, left, right are the arrow keys on the keyboard. The escape key, and then key down and quit are two game states that we search for. Okay, so these allow us the keyboard controls. You can easily access all of the keyboard controls. You can also, there's a whole library for game controllers for using the mouse in the games. All of those things are accessible here, but you're going to import those locals. And the reason that we're doing from pygame.locals import is so we can just address these directly by name. So when I want to use this in my code, I'm just going to say k_up, and instead of saying pygame.locals.kup. It just makes it a little easier shorthand. Okay, the next thing we're going to do is screen width and screen height. You'll notice we are defining these constants, and the reason for that is because your screen's not going to change. Once it's established, it needs to stay the same size for the game to work properly. But we're establishing these and we're putting them in as variables because we will use these constants throughout our code in different ways. So screen width and screen height are constants that we are creating. The names screen width and screen height, by the way, they're arbitrary. That you don't have to name them that, but for the purpose of this, it makes sense. Okay, so now we're getting into creating some of the sprites in the game. We're using a class structure here. A lot of this should be familiar to you because we did cover this, but we're creating a class called player, and that class is based on pygame.sprite.sprite class. So there's a generic sprite class in Pygame that gives us all the things that a sprite needs to do. It helps us with collisions and management and drawing it and all that stuff. So player is going to inherit that stuff plus a few things. So this is going to, the initialization or the constructor here refers to that. So it calls a constructor for sprite. And then we have, you'll see self.surface.surf. So that's short for surface. Pygame.image.load. So we're loading that image. We're assigning that as the surface. Set color key tells Pygame what color is going to be transparent. Remember the jet with the white box around it? We're getting rid of the white. That's 255 times 3 there. That's white. Gets rid of those white pixels. RLE accelerate, what we just talked about, is the constant that we use for hardware acceleration. So it actually makes it draw that more efficiently and knock that color out more efficiently. If this was a hardcore computer science class, we would crack this baby open and look at the algorithm. We're just here to make games, people. So we're just going to trust that works the way it's supposed to. Okay, so we are creating now the rectangle. Remember, surface and rectangle are the two parts of every sprite. Self.surface.get rectangle says make the rectangle equal to the size of the image. That's it. So use the surface, use a method of the surface called getRectangle to get the dimensions of that image, and use that for the rectangle. So what we're saying is the hitbox or the rectangle for this sprite is the same size as the image. You can easily change that to smaller, bigger, whatever you want to do. Self.rectangle.top, we're setting the position, the position of the top of that rectangle to 250 pixels down. If you remember, it's a 600 pixel tall screen. Maybe this pen will actually work. Yay, it does. Okay, so let's take a look at this screen here. So we've got a screen that looks like this, and it is 800 pixels wide by 600 tall. And we're telling that sprite that the top of it, right here, is at 250. So we're just positioning that. If we don't tell the left-hand side of it where to be, or we don't say where to position it this way, it's just going to be 0. So this corner is 0, 0, and this is 800, 600. So that's how we position things in the screen. The numbers get bigger as you go toward that corner. So now we've initialized that player class. We are providing a method of that class called update. This is what happens every game cycle. The first thing that we do, an update takes pressed keys as an argument. So what we're saying is pressed keys is an array that contains all the keys that are currently being pressed. And you'll see here that we've got an if for each of the arrow keys, up, down, left, right, because those are the things that you'll use to control the airplane. You'll also see that they're each their own if. The reason for that is because you could theoretically be pressing more than one key at a time. If you want to go up and to the right, down to the left, so on. So if the up key is pressed, you're moving 0 pixels horizontally and negative 5 pixels, I'm sorry, 0 pixels, yes, negative 5 pixels means you're moving up 5 pixels. Down, you're moving positive 5 pixels, left and right, okay? 5 pixels each. I can change the speed of the airplane's movement by increasing or decreasing this number. Or maybe I want it to be able to go up and down more quickly and move slower left and right. I can change all of that by playing around with these numbers. And it really just attaches the movement of the plane right there to those keys. The other thing that we need to do is keep the player on the screen. So what we're saying is the left-hand side of the rectangle, the left-hand side of that rectangle off the screen this way, is it less than 0? Because in Pygame, what the game engine actually sees is a margin around the screen that you can't see. So it'll actually track the player off of the screen if you allow it. But if you say, if it's less than 0, just set it to 0. What that means is it's never going to go past that. Same with this. Okay, so we're seeing these constants come back. The right-hand side, if the right-hand side of the rectangle is greater than the screen width, okay, so if it's over here, stop it. Set it to just the screen width. We got top and bottom. You can see we can get a position for the top, right, left, and bottom of the rectangle, which allows us some pretty precise coordinates. So that is the two things. We have the constructor method, and we have an update method that basically says we're going to check and see if we want to move the player, and also after we move the player, we want to make sure they're not off the screen. That's it. That's the whole class for the player. Now we're going to look at the enemy class, which is again an extension of the sprite. I have a reference to global here because we're going to use the enemy class to increment the score. When it goes off the screen, we're going to add 1 to the score. So this is calling the super constructor. And then we have, again, the surface. We're loading it. We're setting the color key so that the background is transparent. And we're setting the rectangle. We're using an argument here that we pass to rectangle to set the center of that image to these coordinates. Okay, so if you look, the center of each missile is going to be somewhere off the screen over here because we want them to fly onto the screen as if they're coming from some other source, right? We don't want the missile just to appear here and then fly. That looks dumb. It looks much cooler if they fly on. So we're going to create them, we're going to spawn them over here, and then they're going to fly in. And that's why the width, you see we have an X coordinate and a Y coordinate here. The X coordinate is somewhere between screen width plus 20 and screen width plus 100. So we're going from 20 off screen to 100 off screen. And then the vertical placement is 0, between 0 and screen height. So we're going between 0 and screen height for vertical placement. So that means we've defined kind of an area like this where the missiles can appear off screen. And then they all fly onto the screen that way. Okay? So that's where we're spawning those enemy sprites. And then they have a speed, okay, because their speed is randomly generated. We don't want all the missiles to fly the same speed. That's also boring. So we're using random again to move between 3 and 10 pixels per cycle. I think it's fun in the game if the player is moving at 5 pixels per cycle to make the missiles potentially moving faster than that. It makes it more difficult. So you'll notice the enemy also has a method called update. The reason that all of our sprites should have an update method is because it allows us to use a group of sprites as a way of calling the update method on everything simultaneously. So if I tell all the sprites on the screen, hey, update, they all do what they're supposed to do when I tell them to update. And what the missiles are supposed to do is pretty simple. Two things. It moves at the negative of self speed. So we're moving to the left at whatever that speed is and not vertically at all. Although you could change this to make it more interesting. If you want to figure out how to make the missiles a little bit more like heat-seeking missiles, you can have them follow the plane up or down just to make it a little more interesting by figuring out how to change this value. Right now, they just fly straight. And then if self.rectangle.right is less than 0, what that means is if the right-hand side of the missile has gone completely off screen to the left, then kill that sprite. This is a method that is inherited from the sprite class. All it means is it just make it go away. It's really simple, and it takes care of reclaiming the memory from that sprite. It does all these things behind the scenes that you don't have to worry about, because all you have to say is just kill it and add 1 to the score. So if it goes off the screen, we kill that sprite, we add 1 to the score. It keeps the game from blowing up your computer by constantly absorbing more memory. Next thing we do is we initialize the game. You'll notice that before I have any set values here, where I'm using pygame.font or pygame.display, I have to initialize pygame. So I want to do that first, and then I can start building the rest of the game. And because normally these kinds of things I would want to declare up at the top of the code. I can't do that because I hadn't initialized Pygame. So Pygame initialize, set the score to 0. I'm creating a font for the score that's basically the generic font in Pygame at a size of 36 pixels. That's just where it's created, the size there. I'm creating the screen now, screen display set mode. There's the width and the height again. This is where I'm actually telling the screen to be that size. So it's nice to have those constants available because then I can use them throughout the code. If I want to change the screen size, I just change it in one place. Okay, so now we are creating a custom event. Events are things that happen either when something happens on screen, a collision, or or the player achieves something, or something happens. But what we have to do is create a timed event that will spawn a missile that creates the missiles on a certain time interval. And so what I'm doing is I'm creating a custom event called add enemy, and it's pygame.userEvent +1. Basically, what that means is we're adding whatever the event number is in the game +1. That way we don't have to worry about what that number is. It just creates a random number for us and assigns it to that event. And you can see Pygame time set timer. It basically is saying every 250 milliseconds, trigger that event. Just do it. Just put up a flag and says, we're going to add an enemy. This doesn't actually add the enemy, by the way. This just says it's time to add an enemy. So it's just a reminder. It's like setting a reminder on your phone. Remind me every Tuesday or every morning at 10 a.m. to feed the dog. It's basically saying the same thing. Remind me 4 times a second to add an enemy. So if I want more enemies at a faster rate, I can change that number. I would make that number smaller. If I set it to 100 milliseconds, then it's doing it 10 times a second. So play around with that, and you can make the difficulty different. Okay, I'm creating an instance of the player. This is where this object-oriented stuff gets kind of cool, because if I wanted player 2, I just create another instance of the player. And I allow it to have different keys mapped to it. But then all of a sudden I have 2 players, a 2-player game. So this is pretty powerful construct, a pretty powerful way to do things. But I'm creating a player here. And next, after I create the player, I'm creating some groups. I have a group called enemies, and they're called the sprite group. It allows you to do things with a group of sprites or a whole bunch of sprites all at once. So if I have a swarm of missiles on the screen, I can tell them all to run their update method just like that. So I have a group called enemies and a group called all sprites. So the enemies is all the missiles. All sprites includes the enemies and the airplane. So I can call the update method for everybody at once if I want to. So I have all sprites, enemies, all sprites, and then in all sprites, I'm adding the player to all sprites. I haven't created any enemies yet, so I'm not adding them. Remember, that's handled when we respond to the custom event. Now I'm getting ready to start the game loop. So I'm setting running it to true. So to stop the game, all I do is set running to false. And I'm setting up a clock instance that will control the timing of the game. In other words, slowing it down. Last thing before I start the game loop is I have a very quick method to just draw the score on the screen. So it renders, it creates a score using that font. And then you can see our first use of blit here. It draws it on the screen. I'm not calling this method yet, so it's not drawing the score. I'm going to put the background down first, then call the score. Actually, I'm going to call the score last, so sprites go behind it. I'm still questioning whether I like that or not. So I'm using score surface. The surface is just a surface that is like the sprites. It's what you see on the screen, and this is the position of that. So 10 pixels down, 10 pixels in. It'll be in that upper left-hand corner of the screen. Okay, so here is the game loop. It's going to follow the exact pattern that I just talked to you about. And it says, while running, first check all of the events in the game event get. So what are all the things that have happened in the game since the last cycle? So for each event in Pygame event get, if there's a keyboard press, right, then we check to see what the key is. Did we press the escape key? If we did, quit the game. If we close the window, quit the game. Those are the first things it checks for. Now, what we see is the custom event. If the event is add an enemy, then we create a new enemy, we add it to the group, and we add it to the other group. That's it. To create a missile, because we did all of that work when we defined that class, all we say is, yeah, just create that thing. And it does what it's supposed to. Now we're going to see what keys are pressed. So it's going to get since the last game loop, what are all the keys that have been pressed in an array. It's going to pass that array to player.update so we know whether to control the player or not. Any other keys, if it was the escape key, it's going to quit the game. Any other keys are just ignored. But if it says, if any of those keys are pressed are the arrow keys, it's going to move the player accordingly. So it's calling player.update. Now look at this. This is where the sprite groups get really handy. If I have 100 missiles on the screen and I call enemies.update, it will run the update method for all of them simultaneously. Super quick. Like, you realize that you're actually updating the position and the collision and everything for hundreds of objects on screen with one line of code. That's why Pygame is so great. Okay, so now we run the update. We haven't drawn them to the screen yet, by the way. We've changed their position in memory, but we have not drawn them. So now we're going to start drawing the screen. Screen.fill fills it with that blue color. So you change that value, you change the color of the screen. Next, we're drawing all the sprites. And again, for entity, for each thing in the group, all sprites, screen.blit, draw that on the screen, the surface, and the rectangle. Again, hundreds of objects drawn on the screen with 2 lines of code. Then we call the draw score, because that's the top layer. Next, we check for collisions. This is really cool. It's pygame.sprite collide any. So if there's any collision between the player and any sprite in the enemies. So we're checking for, again, 100 different collisions in one line of code. Kill the player, set running to false. This is where you would put, if you wanted something to happen, because right now the game just quits. You get hit by a missile, the game just quits. It's kind of boring. It doesn't have an explosion or sound effects or a game over sign. You don't have multiple lives. Like, this is where that would be handled. What happens when the collision happens? You kill the player, you turn the game off. Boring, but simple. So this is where you'd put that. And then the last thing, once everything's drawn, once everything's decided, who's dead, who's alive, what's collided, all that stuff, we flip the screen. Just like the flip book, flipping the next page. And then the last thing we do is we're like, we better wait a little bit, because if we don't, this game's going to be running way too fast. So we're setting it at 60 frames per second, which is relatively quick. But you can change that again, you can change the game speed to make it more difficult or more simple. So now we have the game that looks like this, where I can fly around and dodge the missiles. Now, the thing that's not great about this is that the speed of the game never changes. So a player with a moderate degree of skill could play this game infinitely, which is kind of boring. So let's look at a way to make the game progressively more difficult as you play it, because that's like any basic game sort of has that one feature. So let's go back up here. I'm going to make the game progressively more difficult by changing the speed of the missiles progressively over time. And this is really easy to do because I already have a how long has the player been alive measure, which is called the score. So the higher the score is, the faster the missiles are going to go. So I'm actually going to take the score and divide it by, well, I'm going to divide the score by 15 using floor division. And I'm going to add that to a base integer to come up with the slow end speed. So the bottom end is going to increase 1 point or one pixel for every 15 points I get. The top speed is going to be 7. It's going to start at 7, and it'll increase 1 point for every 10. So what's going to happen is we're going to start here. Like, this is the slowest speed possible for a missile, and this is the fastest speed. So this one's going to increase slowly, but over time that range. So I'll still have ones that are kind of slow, even though the slowers are going to get faster. The faster ones are going to get really fast. So I'm going to take this, I'm going to uncomment those lines, and then I'm going to just plug those in here, just like that. And now I have a progressively more difficult game. It starts out almost too easy, but you can see here I'm already ratcheting up the speed, and the faster, let's see how long I can actually talk and do this at the same time. You can see now that they're starting to get pretty fast. So eventually I am going to lose. If I wanted to do another thing, I could have the score decrease that time interval. But they're getting pretty fast now. And they will get infinitely faster, by the way. Okay, this is going to be on purpose. I just don't want you to think I'm bad at this game. Anyway, so there's lots of different ways that you can tweak little things to make the game more difficult. You'd be surprised if I allow the missiles to go up or down by a few degrees based on where that plane is. The game gets super hard really fast. I played around with that. It's kind of crazy. You can actually have the missiles actually turn in a full 360 degrees to follow the plane. So you can do all kinds of stuff just with that simple mechanic. The thing about this game is that with a few tweaks, I can do all kinds of things. I could allow the plane to shoot. I could make, instead of a plane, I could make it into a car that has to change lanes to avoid oncoming traffic. I could say, turn the orientation so that I'm now dodging things that fall from the sky. I could change the orientation and flip it so that instead of trying to dodge things, I'm trying to catch things. So it could be like, I don't know, a dude outside who's trying to catch snowflakes in his mouth or something like that. So there's a lot of different ways that you can modify a simple game mechanic. And that's what I was saying is, in 1985, you had 25 different games in an arcade that were all basically the same engine or mechanic without really doing anything except changing the graphics and flipping to whether you're dodging or catching. But you can really play around a lot with this. So on our next session, I'm actually going to take this code and modify it to be a completely different game. But what I would suggest for this time around is try downloading the code. It won't run until you have those sprites in place. So find some sprites to use, and then try playing around with some of the basic numbers and tweaks in that code. See if you can get it to do something a little bit different. And then next time I'll show you how to take that game and make it really different. So anyway, that's kind of the game plan moving forward.